All right, you're going to want to get extremely familiar with radians so that filling out a table like this becomes very simple. But as you're getting started, it's pretty easy to determine radian values for given angles and degrees by either performing a simple mathematical calculation or by just comparing the relationships between the sizes of the angles. But to start with, you really do have to memorize, learn a specific fact. Most people either memorize that 360 degrees equals 2 pi radians, or they memorize that 180 degrees equals pi radians. Um, Hopefully, whichever one of these you choose, you can quickly establish the other one. For example, if we had memorized that 180 degrees equals pi radians, we could just double 180 degrees to recognize the relationship between 360 degrees, and then just double pi to realize that uh, uh, 360 degrees and 2 pi are equal as well. With any of the other relationships, we can do a kind of similar proportionality kind of game. For example, since 180 degrees, or since half of 180 degrees is 90 degrees, we could just take half of pi and get pi over 2 to recognize that 90 degrees equals 100 and equals pi over 2 radians. And this kind of pattern can be followed throughout. Let's do one more. In fact, we could take half of 90 degrees to get 45 degrees. So why don't we take half of pi over 2 radians to get pi over 4 radians? The relationships are proportional to each other. So once we establish one relationship, we could quickly find all sorts of other relationships. But another option, besides using this sort of proportionality, is to just focus on a particular angle and kind of manually convert it from one unit to the other. So like, let's say we want to convert 30 degrees into radians. What we can do is we can take 30 degrees and we can multiply it by the number 1 so that we don't change 30 degrees, but the version of the number 1 we'll use will come basically from one of our other columns in this table. For example, we could multiply by 180 degrees divided by pi radians, and the fact that the 180 degrees is in the bottom of this fraction. The degree units will cancel, and we'll get radian units out of this. So we'll get 30 pi over 180, and these are going to be radians. And then we can just reduce this fraction. There's 6 30s inside 180, so we could have 30 times pi over 30 times 6 and cancel the 30 and end up with pi over 6. So 30 degrees is pi over 6. Similarly, we could sort of manually convert 60 degrees. 60 degrees times how about this time we use our other relationship, this one right here, 360 degrees is the same as 2 pi. And we can work this out now. Why don't we just go ahead and kind of immediately cancel our fractions. There's, well, I'll write, that's not right. All right. 360 as 60 times 6. Our degrees actually have already canceled. All right. Our degrees cancel here. And now we can cancel our 60s and get 2 pi over 6, which reduces as pi over 3. Pi over 3. Now for an angle like 270 degrees, we could kind of go in either route. We could take 90 degrees and triple it to find 270, and therefore we'll have to take a pi over 2 and triple it to get 3 pi over 2, the equivalent of 270 degrees. And we could also do the kind of manual conversion as well. And the one cell that's missing that we haven't filled out is 0. It turns out that 0 is possibly the easiest of all. 0 degrees equals 0 radians.